Chapter number 14, exception handling. So let's go through the built-in exception provided by Python. So there are a couple of dozens of exceptions provided by Python. I'll just go through a few and then you can pause the video and then read about all of this. So arithmetic error, the first one, raised when an error occur in the numeric calculation. So um, whenever there is a exception occurs when doing some numerical calculations, you get an arithmetic exception. Assertion error, so raised when an assert statement fails. Uh, Now, the exception, the first level of exception is base class for all the exception, and from this exception, the further down if you go, you get different level of exceptions. So you can see floating point error, for example, raised when a floating point calculation fails, and so on and so forth. So I would recommend you to pause this video here and then read um, this first set of exceptions. I will go to the next. So this is the next set of exception provided by Python. So you can see syntax error and runtime error. Runtime error is an important one. So raised when an error occurs that do not belong to any specific exception. And yeah, just pause the video here, go through all of this, read all of this. Moving on. So we have just gone through a list of exceptions provided by Python. Now, how do we treat these exceptions? So if suppose one of these exceptions occur in your program, how do you deal with it? How do you programmatically handle this exception? So for this, Python has provided us with a try, exert, finally block. So try block lets you test a block of code for errors or exceptions. The except block lets you handle the error, and the finally block lets you execute the code regardless of the result of the try except block. Now let's see two examples to get our concept clear. So to start with the exception handling. So this piece of code, I've got the print statement, and so for now, let's see, I comment this, all of this, and then run it again. X is not defined, yeah, name error. So I'm getting a name error, and so if we go to, let's find, there you go, name error. Say third last from the bottom. So raised when a variable does not exist. Yeah. So we just proved that we reproduce this. So let's try and wrap it around our try catch, try exert block. I keep saying catch because in Java it's called catch. So again, we don't have a variable x defined. But whenever there is a name error occurs, I want to catch it in this exception handler. Any other, suppose if there are n number of line of code instead of one line of code, and if it is not a name error, if there is something else error, then I've got a general block for except which will handle the base exception, and it'll print something else went wrong. And then this line of code finally will get executed if the exception occurs or not. So let's run this line, this program. So basically I'm getting variable x is not defined, which is going inside this except name error. Um, and yeah, it doesn't go inside this, but it does go inside the finally block. Yeah. Now let me change this to something else called arithmetic error. Yep, so I'm not catching a name exception, I'm catching an arithmetic exception. So what should happen is it should not go inside this, it should go and get caught inside this generic exception handler block. So let me save and run this, and things will get clearer. So I got something else went wrong, which is going inside this block, and then it is saying finally block try except is finished. Yeah. So there you go. We just went through a simplest form of um, explaining of try except finally block. Now there is one more variation to this. Suppose you don't want to you want to raise your own exception instead of Python program throwing an exception. So here what I've done is I have defined a variable x with -1 value, and then inside this try and except block I I've, I've said if x is less than 0, so our value of x is -1, then raise a arithmetic error. So I'm raising an arithmetic error in this line. So because we have got try and catch block, it'll try and run this piece of handler code, and it will check if there is arithmetic exception. If there is arithmetic error, then it'll print this. If there is a generic error, it'll print this, and it'll print finally always. So let's run this program and let's see what happens. So I'll run the raise exception, and you can see the variable x can't be negative. So it ran this piece of code, line 12 and 13, because we are throwing arithmetic error in line 11. Now, for some strange reason, I don't want to raise an arithmetic error. I want to raise a name error. Yep. Uh, or connection aborted error, just for the sake of it. My connection got lost and I got connection aborted error. And I want to run this. So it won't get caught here in my arithmetic error block, but it will get caught in the except block, which will try and catch the base exception. And then finally is getting caught. Now, in programming world, it is always good to keep this base exception at the last, and you try and catch a smaller exception first, so that you can handle it nicely. Like if there is connection aborted error, you handle connection aborted error and do whatever to do with connection aborted error. If there is name error, you do specific thing for name error, and then you do a very generic thing for base error. So that's it for our exception handling. Um, thank you. I have provided the links in the description below for the Python and PyCharm download. I have also recommended 3 Python books to enhance your knowledge. If you like this video, please like, comment, subscribe, and share. Thanks for watching.